Okay, the quadratic formula. This formula is great. It's right at the bottom of the page here. It's kind of big, a little bit intimidating, but when you get rolling with it, it is nothing to be afraid of. Just like any other equation solving or algebra, you just got to be careful with your negatives and make sure that you're using a calculator the whole way through here. Our learning goal is that we're going to be able to solve polynomial equations by using a formula, which is the quadratic formula. So it says solving a polynomial equations means determining the values for the variable that makes the equation true, right? These values are called the solutions to the equation. So far at this point, we know that we can solve these quadratic equations by factoring, right? Sometimes I give you a quadratic something like here. Let me go ahead and actually write it in here. If I gave you x squared plus 5x plus 6, right? Something like that. And if you wanted to solve this here, let me do it a different color. If we wanted to solve this thing perhaps by factoring, well, we'd have to first factor. So looking for two numbers that multiply to 6 and add to 5, the numbers are 2 and 3. And at this is factored. And now if we wanted to solve this quadratic, we would take each of the factors and set them equal to 0. So x plus 2 equals 0, and x plus 3 equals 0. And then we just solve for x. And really, there's not much to do here for solving for x, because we just take the positive 2, bring it to the other side, and we get negative 2, right? And you might find this extremely familiar, right? X equals negative 3 over here, because we just bring the positive 3 to the other side. And that might be familiar, and that's all we know so far about solving quadratics. Now, the question is, what if these quadratics were not factorable? I mean, sometimes quadratics are not factorable because they simply have no solutions, meaning they have no x-intercepts. But other times, quadratics are not factorable if the solution is really, really nasty, like just a crazy decimal that doesn't sit too well with us. So that's why we have this quadratic formula. It'll be able to tell us what the solution is, or what the x-intercepts are. And okay, we're going to be solving polynomial equations which are quadratic. We certainly know that. And the solutions to these quadratics are called the roots of the equation. And on a graph, we call them zeros. But roots and zeros, they all pretty much mean the same thing here. So the quadratic formula, here it is. It's a formula for determining the roots of a quadratic equation. And we've got to make sure that the quadratic equation is in standard form. See how it's ax squared plus bx plus c equals 0, right? And I write here that a cannot equal 0. And I mean, that's more for me, because if a was 0, for example, there would be no a value, and then it would be a linear equation. So that don't worry too much about that a equals 0. That's more for me to make sure that I'm giving you the right information, but that'll never come up anywhere. The formula just uses, like here's the quadratic formula at the very bottom here, and it uses the a, b, and c values from standard form in this formula. So for example, wherever you see an a, you're going to put the number that's out front of the x squared. There and there, right? Whenever you see a b, the same thing. You're going to, now this one's, you got to be careful with this first one. B there, B there. And then C, there's just one of them, and it's right here. Now, the only value to be very cautious of is the B value, and I'll tell you why. If you have a look at this quadratic equation, the first thing here is negative B. So it's like really trying to mess you up a little bit, but that's what I mean. But you got to be really cautious here, because if you sub in a negative number for B, it'll end up being positive. But if you sub in a positive number for b, it'll end up being negative out front of here. Now, inside of the square root, or underneath the square root, you know, it's pretty much fair game. And of course, this whole thing is dividing by, it's everything. You're dividing the entire thing by 2a. There is one symbol in this quadratic formula that you probably haven't seen before, and it's this plus minus symbol. We call that a plus minus symbol. And what it does is you can kind of ignore it for a little while until we get to a point. And the plus minus symbol really means that it's like a fork in the road. On this side of solving it, you're going to use the plus, and then you're also going to solve it again, but by using the minus. So what is the plus and minus symbol? Well, it means both plus and minus. So for example, if I asked you, hey, what's 3 plus or minus 1, right? And you're like, well, that doesn't really make much sense because it's plus or minus, but really it just means plus and minus. So let's just say on this side we'll do the plus. So this is going to be 3 plus 1, and that equals 4. Great. And over here this will be the minus. So how about 3 minus 1? That equals 2. So our two answers here would be, well, 3 plus or minus 1 is 4 and 2. Okay. And that's essentially what it is here. It's just in the middle of a nasty equation, but doesn't seem so nasty when you get the hang of it. So let's do an example, and I'll show you what this thing is all about. It says here, use the quadratic formula to solve each equation, round to 3 decimal places. I mean, you could really use more than 3. I know some students are so good at using their calculator that they just want to hold the entire decimal place, which I think is great. But I think a good median here would be using at least 3 decimal places. So here's our quadratic. We have 2x squared plus 15x plus 1. And if you try to use the magic x here, what are two numbers that multiply to 2 and add to positive 15? There's not. Is there? Yeah, I don't think so. Multiplying to 2 and adding to 15, there's not really anything there. So what we can do next is pull out the a, b, and c values. So we got to remember, we got to look carefully at this quadratic and make sure that it's in ax squared plus bx plus c form. So what I'm going to do is I'm going to write that in just above it. Ax squared plus bx plus c form. And if you put this over top, I mean, if you space it out a little bit better than what I have here, notice that it's already in this wonderful form. So there's no real tricks here. Sometimes the textbook might try to trick you. They'll jumble them around. And it's like, come on, what are you trying to do to me? But it's okay. We got A is 2, B is 15, and C is 1. Now, I highlighted just the number. Really what I should have highlighted is also the sign with that number. This will be a positive 15. This will be a positive 1. So when we go ahead and fill these in, I like to write them on the side. I extrapolate the information from the quadratic. And I know, all right, A equals 2. All right, B equals 15. All right, C equals 1. Lovely. Now with this formula, what we're going to do, we should always start off by writing the formula down just for math form. In the next step, we're going to substitute the values of A, B, and C into their locations here in the formula. So here's what that'll look like. Remember, it's negative b plus minus the square root of b squared minus 4ac divided by 2a. All right, so negative 15, right, negative b, plus or minus the square root of 15 squared minus 4 times 2 times 1, all divided by, notice how we're dividing everything here, all divided by 2 times 2. So in our next line here, we're going to simplify everything. I highly suggest, like usually the bottom part is pretty simple, 2 times 2 or 2 times whatever the number is. It's not incredibly difficult math. But this underneath the square root can get a little bit tricky. And we've got to be very careful. So what I would suggest doing is pulling out your calculator and typing it in exactly as you see it. Now don't use the square root just yet. Just calculate everything underneath it. So open up the bracket, 1, 5, close the bracket, squared, minus 4, bracket 2, bracket 1, and just type it in exactly as you see it. And that's the first thing we attack here. And you should get 217 just underneath the square root. And of course, right, 217. And of course, you got 2 times 2 is 4 for the bottom, right? Now, notice how we can't really do anything else. Like, negative 15, but I mean, sure, we can actually do the square root of 217, so maybe we should go ahead and do that. The square root of 217, the question says to use 3 decimal places, so we do that. Square root of, here, I'm just going to double check this in my calculator, 217, I get 14.7309. Because it's 09, we'll just round that 0 up to a 1, and that's where this decimal place is coming from. Now, at this point, we can't really do a whole lot. We genuinely can't. So this is where we're going to be using that plus minus. Yeah? So maybe on the left-hand side here, we will plus. And I highly suggest you do something like this. Put a little arrow and put a big plus. You're like, okay, this is the plussing side. So you're going to go ahead, negative 15 plus 14.731 divided by 4, and you should get negative 0.269 divided by 4, and finally you get negative 0.067, and that is one of your solutions. Okay? And then, of course, don't forget it's a plus minus, so we also have to minus. So I highly suggest you draw this arrow over here and you put a minus symbol like that. So negative 15 minus 14.731 divided by 4. Remember to simplify the top first, right? You're not new to this. And then we just divide by 4, and we should get something like negative 7.433. And there you have it. These are the two solutions. I mean, not factorable, of course, but we did end up finding two x-intercepts here. Okay, so like if this were on a graph, yeah, this quadratic, we know that it's opening upward because the a value is positive. There's a, yeah, let me just draw the graph here. Or, probably go this way. We would have a x value at negative 0.067, and then one at negative 7, negative 7.433, negative 0.067, and these would be our two roots. Yeah, so the parabola is facing up, so you could draw it in. I mean, really, we could actually solve for the vertex given these two roots, but only if we wanted to. It'd be kind of a nasty vertex, but that's okay. All right, let's try another one. We got x squared minus 6x plus 4. It wants us to use the quadratic formula, rounding to 3 decimal places, no problem. So we double check, and I sometime, I'm telling you, in the textbook, they are going to try to trick you. And they're going to have it in a jump, minus 6x, or b. They are going to try to trick you, I promise, so just be very cautious of that. So I line this up, and I'm like, oh, okay, we're in good shape. So notice how there's nothing here with the x squared. Well, remember, there's a little imaginary 1. Not imaginary, it's actually there. We just don't write it. So 1x squared minus 6x plus 4. So our a value is going to be positive 1. Our b value, have a look, it's negative 6. And then our c value, have a look at the sign, it's positive 4. So what I like to do is totally extrapolate that information, write it off to the side for sure, and then we have it just like that. So we don't even have to look at the quadratic anymore. We can just look at this little box here with a, b, and c. We should always write out the quadratic formula. All right, and now we're going to plug everything in. So have a look at what this looks like. Negative 6 squared. Sorry, negative 6 plus or minus square root of negative 6 squared minus 4 times 1 times 4, all divided by 2 times 1. Okay. Now this is where you have to be extremely cautious. Be very careful. I'm going to write the word careful here. That first negative b is extremely scary a little bit because notice the double negative, it's going to eventually become a positive. Yeah? Again, everything under the square root, we want to just plug it right into the calculator because if we start doing this in multiple steps, it's just a lot to write down. So, and 2 times 1 is just 2, right? So that one's not so bad. So when we simplify this all in our calculator, we should get root 20, right? This should result in 20. So maybe you could even give it a shot right now in your calculator. Type it in as you would, and you should get root 20. 4 times 1 times 4. And I get positive 20 under there. And notice the 6. The 6 is now a positive 6 because the two negatives kind of cancel each other out. And of course, we're not surprised. 2 times 1 is just 2. Okay. Next, what we can do is we can actually do the square root of 20. which gives us about 4.472 root 20. It really it's 4.4721. So the 2-1, we don't really round that 2 up anywhere. So we're keeping it at 3 decimal places. You could use the whole thing if you wish. And this is where we kind of break off. We say, okay, over here we're going to use plus. So we're going to add over here. Notice how we're just adding, just like that, right? So 6 plus 4.472 over 2, we simplify the top of this fraction, divide it by 2, and we get an answer 5.236. Some of the questions in the back of the book, they might have just 1 decimal place. They might. So maybe the final answer, they might round it to 1 decimal place, but I do like 3. I do like 3. And then on the other side here, we are certainly going to subtract. Now, if you already got the hang of this, just please stay with me here. 6 minus 4.472 divided by 2, okay. We simplify the top, not so bad. We divide by 2, and of course we get a second answer. And there you have it, right? There's just a few things to be cautious of, but after a couple of runs with this, you're going to be on your way, and you're going to be so good at this. Okay, one more thing. Sometimes in the textbook, I think I might have stolen this next one right out of the textbook. They give you something like that, and you're like, all right, well, I got to figure out what the A, B, and C values are. So how about for this one, we just say, all right, what are the A, B, and C values that you would use in the quadratic formula? Sorry, just tough for space here. Now, this is kind of nasty. It's very similar to some of the questions on that in-class assignment we did. What are the A, B, and C values? Well, it doesn't look so pretty here. We got x plus 4 squared equals 2 times x plus 5. Okay, so what we would do in this situation is we would just expand, and simplify. So what do I mean by that? Well, the x plus 4 squared is really x plus 4 times x plus 4, right? This right side I haven't done anything to just yet. And we can continue expanding by using FOIL, right? We can FOIL this out. And also on the other side here, we can use the distributive property. Check that out. So lots of expansion going on here. X squared plus 4x plus 4x plus 16, 2x plus 10. Remember, when we FOIL, we are multiplying, right? And when we distribute, we are multiplying. Okay. Now, let's tidy this up. 4x and 4x can kind of be combined into 8x, right? And now we're left with this. Now, some students might say, hey, I'm going to stop right here. This is my A, B, and C value. I see it. It's like, well, not really, because that form that we're looking for, the ax squared plus bx plus c form must equal 0. Yeah? So we want to make this thing equal 0. So what we're going to have to do is we're going to have to bring these terms over to the other side. And what happens is they change their sign from a positive 2x to a negative 2x, from a positive 10 to a negative 10, right? And I highlighted them in red just to say, hey, look what happened here. They didn't magically just come to the other side of the equation. No, they didn't. They actually had to change their sign when they do that. But some students might say, oh, okay, take away 2x from both sides and take away 10 from both sides, which is really what's going on here. This is just kind of a little shortcut. Now, notice that we have some like terms, right? 8x is like term with minus 2x. And also, positive 16 is like term with negative 10. So we're going to combine our like terms, and we end up with x squared plus 6x plus 6. Yeah? And that, notice, yeah, when we put this over top, that looks good. That looks good. That'll work. That'll do. And so I think we're just going to end off and say, okay, well, therefore, A would equal 1, B would equal 6, positive 6, and C would also equal positive 6. Yeah? Okay. Now, there's some homework here. Page 343. It's a great question, very similar to this example right here, number 1. 3 ACE, 4 ACE, 5 CD, 9 AC, they're all pretty well just using the quadratic formula. But there's some situations where you might not be able to complete the quadratic formula, in which case there's no solutions. In some cases, you might have one solution, so just be cautious of that. And then I put a star beside this number 15 because it's a tough one, and I know it's a tough one, and I'm interested to see how you might solve it, because I think it's a great question. When you read it, there's not much to it. It's a very short question, and it makes sense. I'm sure you could draw it out, but the way you attack it is really, really, really interesting and really cool. So I'm excited to see what you get as an answer. And if you need anything, of course, let me know. I'm always here to help. But until then, folks, this is the quadratic formula. This is what you might hear the grade 11s talk to you about, the quadratic formula. It's such a cool formula, and it does so many good things in grade 10, 11, and 12. So here it is. Let's practice it. If you need anything, let me know. I'm always here to help. Take care.